Because they had like giraffes in China, and that's how they can prove it, because they found giraffes in China.
Okay,
No, it's just
we're
Korea.
going to take the exact same problem here, but now I want to take it around the line x equals 7 instead of around the y-axis.
Nah, I'm good.
This is actually easier. This is so much easier than this method. So much easier than this method. So if I want to go around the line x equals 7, that'd be 1, 2, 3, 4, 5, 6, 7. That'd be a vertical line out here. Ooh, I should probably not have done that tool. Okay, so if I'm going around that line, I think we just change the radius. Because would the function minus function part change? Nope. It is. It's only the radius you have to change to go around a weird line. It's lovely. So, yeah, we just have to change the radius. The question is, how do we change the radius? Everything we just did here is going to be exactly the same, except we have to make one slight change in the radius. What was our function? X cubed minus 1. Okay.
7 minus x, x minus 7.
Okay.
7 minus x
Because you have to realize
plus the...
the rectangle is located at some x coordinate. The radius, if you're now going around this blue line over here, the radius is the distance between that blue line and whatever x coordinate you're at. So how would you say what's the difference between those two? 7 minus x.
From right to left, like
Yeah, still right minus left. Yep. So you would just change your radius to 7 minus x. Well, that's the only thing different you have to do. You would still integrate between the same numbers. Nothing else would change. Okay, what if I had said, let's go around the line, actually it doesn't matter, x equals negative 4. This line over here.
x plus 4.
So now, once again, only thing you're changing is the radius. Oh, what I do? So if I'm going around x equals negative 4, it's still 2 pi. It's still x cubed minus 1. All right. Because now you're going to go, my x coordinate's over here at the rectangle, my line's over here, so to find the difference between those and get the radius, it's right minus left. So what would actually right minus left do in this case? You would right is x minus left, which is negative 4, so it really becomes x plus 4, yeah. That's all you're doing. That's right. I'll take this method anytime. It's easier to do this too, to go around other lines.
Everything then?
Nope, you can't. Because it's that same old thing. If your function, you have to lay that rectangle in there the correct direction that will meet the functions correctly. If you can't lay the rectangle in their parallel, you can't use this method.
What if you can't do it either way? Is there one that exists?
Not to my knowledge that I've ever seen.
What if you have like an inverse sign and a sign? That'd be impossible, right?
An inverse sign and a sign. An inverse sign
I'm gonna make your
and a sign.
impossible. Like you can go parallel and you can't go perpendicular.
Sure you can. You have to do both on this one.
Both?
You could do either method. Well, are we taking the region that they enclose? Which is only at the moment that one.
Big region.
But it's not enclosing unless we put some other lines in there.
Alright, fine. Then put like a x equals something.
Because if I'm talking about this little region right in here that they actually enclose,
Yeah, that
then
would be doable.
yeah, I can lay the rectangle vertical or horizontal.
No, put in like a y equals 5.
Now I might have to split it into two functions because right there I have some little bit of overlaps. You might have to break it into two functions in places to do some of these, but you could do it. But you want to go where?
I want to do something
Like a
crazy.
diagonal line in it.
You want to put a
Like a negative slope diagonal line.
coming this way?
Nope.
Y equals negative x plus 3.
Alright, I give up. I don't think we're gonna prove them wrong in math terms.
Like that?
There you go. Yep, now I'm just finding all those enclosed around the x-axis. All of the enclosed areas.
in lots of pieces and parts. But I can do it. I can lay a rectangle in there one way or another and get it to happen. I might have to break it into big...
We'll be back to check your work.
I will be impressed if you get done by seminar.
I need to desperately grade some papers. I'm sorry. As much as I would enjoy proving this to you, I would enjoy that immensely, getting to problem solve that, but you haven't seen the stack of tests I have. This deep.
Turn down the floor.
And the stack of computer papers that are about this deep.
Really, you just gotta look and see if they're done right.
So, okay, so I actually want to show you one other one. I thought I duplicated a graph somewhere. Oh, come on. I did duplicate it. All right. Okay. We have to do one going the other way. We need to do one going around the other axis. So this time I want to do y equals x squared plus 1, and the lines y equal 1 and x equals 3, but this time I want to go around the x-axis. So once again, is this a tough one to graph? Y'all supposed to immediately say, no, Mrs. Meyer, this is PUD. Okay, so vertical line at 1, x equals, no, would you all tell me when I'm being stupid? Horizontal line at 1, that was a really, vertical line at 3. And then x squared plus 1 is a basic parabola. Shift it up 1. Be sure you count from the original origin. So shift it up 1 is actually starting right on this line. Okay, 1, 1, 2, 4, 3, 9. So once again, I have that nice little region, but I'm going around the x-axis this time. Which way does the rectangle sit? That's crucial, 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 crucial. Put that something in there first thing. If it's, yeah, it's got to be horizontal. We're parallel to the x-axis, so yeah, we are going horizontal here. Okay, that immediately should tell you then, what do you have to do to your equations? They have to be x equals. If that baby's horizontal, it's x equal. So I'd have to go y minus 1 and square root it. Now, technically it's plus or minus. How do you know whether you need the plus or the minus? We're on the positive side. Very rarely are you going to get the negative side one, but we're on the positive side. Yeah, it's the positive square root. And then the other function is just the vertical line, so we're good on that one. So you're just going to fill in your formula. 2 pi times the radius times f minus g.
And the radius is...
Okay, I saved the radius for last because I have it, if you know what you did your functions in, I think you remember better. So your functions are what minus what? Right minus left. Yeah. 3 minus, but we have to be in y, so 3 minus, well, someday it'll be square root of y minus 1. That was 2 years ago, and I'm sorry, I need to talk to Clint because this is getting bad. 3 minus the square root of y minus 1. Okay, so since you see that you have y's in there, what does your radius have to be? A y. Since we're going around the normal, just plain old x-axis, it's
So
just going to
it
be
can
y.
all the way to the top one, can it?
Now, what are you integrating between? Yeah.
It can be all the way to 10.
Y's in the problem. So look at the y-axis. How high did we go? Okay, remember 0 is down here, so this was actually 1.
Well, we're going around the
10.
x-axis.
Doesn't matter what we're going around, it's what variable's in your problem. You're integrating y's, you get your limits off the y-axis.
Okay.
Always. You're integrating y's, limits are y's. And there would be your result. And unfortunately, I've never had anybody, I've never gotten these worked out because I don't have the answers on this paper. Okay, now you have to prove to me you're brilliant.
Wait.
What?
Why? Why is it just regular y?
because I'm going around the axis. My radius is always the distance from what I'm going around. So in this case, my radius is measured from the x-axis to the rectangle. So if I measure from the x-axis to how high the rectangle is, that's going to be whatever y-coordinate I'm at that moment. Because if my rectangle's here, I'm at a different y-coordinate.
So then on the other one, why did you have, 7?
Okay, that's because I was going around a different line. I wasn't going around an axis.
So if it's on an axis, you never have to add.
Yeah, if it's going around an axis, it's just an x or a y.
Okay.
What I was
Oh,
about,
I understand that.
okay, what I was about to do is I was about to say, okay, so what if I took this one around the line y equals -2? What one thing would you change? Because if I was going around -2, I'd be going around a line down here. I would still have my rectangle parallel. Everything would be the same. I just moved the x-axis. So, am I going to change the function minus function? Nope. I'm only going to change the radius. So, my rectangle is at whatever y-coordinate. My line is down here at -3. How do I find the distance between my rectangle and that red line? Because it's top minus bottom. Top minus. So it's y, actually minus -2, yes, in this case. Technically it's y minus -2, but which really makes it y plus 2, yeah. Now, if that line had been up above, say it had been up there at y equals 12 or something, then you'd have gone 12 minus y because the line was on top. So it's always top minus bottom and right minus left. Oh, the other thing I should note here that's kind of handy to know about shell method, when you did that, we just did, to get the radius, we just did top minus bottom. To get the functions, we did right minus left. Those will always be opposite. If your functions were right minus left, the radius will be top minus bottom. They're always opposite. So that's another way to check yourself, am I doing this right? But really, you'll find shell method way easier. You're going to like it. It's just a lot less headache to me. You are only doing shell method today. That is it. You are shelling. End of story. And so now we can watch our fun and exciting 10-minute video.